Chris Terra. I work in Ford Product Communications, and I'd like to talk about the efficiency of the 1-liter EcoBoost. Just won the International Car of the Year award yesterday. The car is highly efficient, extremely responsive, and very fun to drive. Thank you for driving with Ford Motor Company.
How fast did we get up to?
The speed limit was 40, so definitely no more than 39. Thank you. This car is actually significantly faster than the car we were just in, even though it's 100% electric.
Really?
Yeah, there's no gas motor in this whatsoever. This is 100% electric powered, very clean. Try not to squeak the tires as to not to raise the alarm of the cohorts. See, now that aggressive braking is only done in the name of environmental responsibility. See, I'm recouping the energy that other would have been lost to the environment by way of heat dissipated from the front discs of the brakes. But I get to recoup that kinetic energy and turn it into stored energy back into the battery.
Miles away in Romeo, Michigan. So our control station is there. So all we have that's down here is a radio on that tower and a GPS base station that gives us a correction signal. So our position is accurate to plus or minus about 2 centimeters, and we do that turn for effect. We've got to go way out because everybody goes, ooh.
Yeah. Jamie's
So the way it works is he's not actually steering the vehicle remotely. He downloads a path file, and the control box under the seat there is actually executing the path file, and it controls the steering and the brakes and the throttle. The path file contains the straight lines and arcs, and we can tell it how fast it's supposed to go on each segment. So it basically executes that path file. So if you look over across the way there where that white car was, you can see that there's a bunch of rough roads out there. Those are representative of what real durability roads look like. You can see how rough they are, all that cobblestones and the big bumps. This is kind of a simulation of that, and you can imagine if it was as long as the road's over there, like a quarter mile, and we're going twice the speed, it would be quite rough on a driver that was attempting to do this. So one of the big benefits of the system is we eliminate that severe input into our drivers, and it creates a really big ergonomic improvement for us and improves the safety of our employees. It also drives the roads very repeatably at the same speed in the same position, and we can get very reliable test results out of it. So that's the primary benefit of the system, and it provides a little bit of efficiency too. And you can see we've got some actuators that control basically cables, and it controls the shifter. The steering wheel is controlled by the motor there, and it's got 2 sensors to tell where the steering wheel is. And then we've got the accelerator pedal and the brake pedal with that pulley mechanism down there. So that's what basically makes the vehicle go. And it'll do this path all day long. If we told it to do it 100 times, it would do exactly the same way 100 times.
So someone is controlling this?
He's at a base station at Romeo, so he has a visual of where it is on the map. He's got a very accurate map, and it'll tell him, he gets feedback on what these actuators are doing, what the vehicle's doing, and then he knows how far off path it is, and then he can, if he wanted to, he could download a different path file and it would run that. So he's in control by downloading, here's the planned path I want